Hi, everyone. Thank you for joining today's webcast on leveraging Google Cloud. So in today's webcast, I'm joined by Ethan, who will take you through some of the case studies. First off, our internal AI Workbench that we've built and deployed at Thorogood for our consultants. And then an example of something that we've done with a customer designing different architecture patterns for the different ways that they use Google Cloud. Before that, I'm Andrew. I will take you through a bit of an introduction on why some of our customers are using Google Cloud or taking a stronger interest in it now, and how we're helping some of our customers get Google Cloud ready and the things that we're thinking through as part of that pattern. So first off, we are seeing an increase in the interest in Google Cloud from across our customer base and the companies that we talked to over the last probably 6 months to a year. Why is that? Well, a lot of it actually is coming from business benefits in particular, maybe rather than the technical parts of the platform. There's a bit of both, but the specific business benefits that people are interested in. First, there's a whole range of AI applications across businesses, opportunities that people see. And we're seeing interest in that from very senior levels in the organization and across the organization as well. Google has some particular capabilities in that area. Of the three major cloud vendors, they're the only one to have their own trained frontier model, that kind of high capability models in the Gemini models. And they built that into a whole package of Gemini Enterprise capabilities alongside Gemini Enterprise Agent Platform, which includes what was part of Vertex AI before. So the capabilities are of interest to a number of our customers. And then to get a couple of more specific use cases that Google Cloud shines in, we've got a lot of customers, particularly in consumer goods and manufacturing, looking at digital commerce, selling direct to consumers through the internet, as well as integrated commerce where you're combining the digital plus more traditional selling. And in those cases, Google Ads data, a lot of marketing teams will use Google to get easier access to Google Ads data through BigQuery, and you can see what interaction there's been with some of those ads. Another example of where it's particularly useful is in geospatial capabilities, and one example of that being personalized consumer experiences. So understanding where a consumer is, and from that, kind of what products might they be able to access easily. So Google has a particular set of capabilities in geospatial from their capabilities in Google Maps and Google Earth. So the majority of interest we're seeing starts with business benefits, but there are also platform benefits that we see customers interested in. So as I mentioned, Google is a leader in the AI space. That's not only that frontier model, it's also some of the infrastructure, the tooling that goes around that. And Google have long been a major player in the machine learning space before AI, with releases of tooling like TensorFlow. So Google have a long pedigree in this space. They brought in the latest capabilities for AI into the models. They're also designing some of the infrastructure that goes around it. So things like the TPUs, tensor processing units that Google has developed to make AI models particularly efficient on their platform. So that second piece here, the end-to-end integrated platform, covers things like the TPUs, things like networking that Google own. They also own all of their own data centers, in contrast to some of the other cloud providers where there's kind of third parties owning and managing some of the data centers for them. And Google make a big deal of that. But the integrated platform covers the infrastructure. It also covers the tooling. So Google will talk about the different tools in their platform being co-designed. So it's not just that they build the individual tools and then think about how you get data or capabilities from one tool into another. They're designing that from the start. To take a quote from Thomas Kurian, the CEO of Google Cloud, while they were launching Gemini Enterprise late in 2025, he said, "The first wave of AI, while promising, has been stuck in silos, unable to orchestrate complex work across an entire organization. Some companies offer AI models and toolkits, but they're handing you the pieces, not the platform. They leave your teams to stitch everything together, and you cannot piece together transformation." Now, he's stating quite a strong opinion there, but it gives you an idea of the principles and priorities behind how Google Cloud, particularly the AI capabilities, but right across the platform really, are thinking about those different tools in combination and how things work together, getting that coherent story of the different components. And so there's a coherence within the platform. Google are also then embracing open source and open standards across the Google Cloud platform in a way that allows you to combine well with tools that come from outside the platform. And that can be particularly of interest and important to companies thinking about optionality and portability and the ability to write applications that run well on Google Cloud, but knowing that you can run them somewhere else later on if you need to, or taking things that you've built on other platforms and running them on the Google Cloud platform. And Google have been active and instrumental in parts of the open source space for many years. If you go back to 2009, for example, they released the MapReduce papers that gave rise to the way we now handle big data, starting with things like Hadoop and then into platforms like Spark that's used for so much of data engineering and machine learning today. With all of those great capabilities available in Google Cloud, if you've decided to adopt it, how do you get ready to use Google Cloud in your organization? So first thing I'm going to do is talk through some of the things that it's worth being aware of when you're designing that approach. So I've worked across all three clouds. I've helped customers design architectures for the three, and I'm certified in each of these three. So I'll try and take you through what are some of the similarities and differences between the clouds. First thing is each of the three major cloud vendors, in terms of like what they offer, what you can do on the platform, they are more similar than they are different. So things like the storage options work pretty much the same across the three. There might be slight differences in the interface, the way that you connect to them, but really they're storing files on a system, and all three platforms can do that. Similarly, if you want to use databases or you want to set up a data lake or put your data in more of a lakehouse structure, there are similar ways to do that across the three cloud platforms. But there are then some differences in how you do that, in how you interact with the platform, in how you set resources up, that it's worth understanding because it can help when you're looking at standard architectures for each of the cloud platforms and understanding how does that standard architecture map onto what you want to do. And also in terms of if you're thinking about moving or changing from one platform to another, how might you do that? So to give a couple of examples of those differences, resource organization is an interesting one. AWS, at the top level, you have the account and most permissions are set. At the top level, user accounts are created within the AWS account, and then individual resources can have tags and you group things using tags. So it's quite a loose system. You can have multiple different sets of tags, and maybe you're looking at resources by billing, or you're looking at resources by the department or the specific project within your organization that owns those resources. You can take various different views across them that way. Within the Microsoft Azure platform, subscriptions are kind of the equivalent of the Amazon Web Services account. So subscription is the top level, and then you use resource groups within that to kind of create a logical grouping of the different resources. So those resource groups are very often used to set permissions. Might be one resource group per project environment combination is a common way to do it. Sometimes it's split down more. In Google Cloud, then, really projects is the unit that you tend to think in. And in some ways, that's kind of similar to a resource group in Azure in that you tend to set permissions at the project level. But in other ways, it's more like a subscription in that when you're looking at a project, you see mainly the resources within that project. Creating connections between resources in the same project is often easier than creating connections between resources in different projects, although you can do it. A project is a slightly harder boundary than a resource group. So there's one way that you have to think about these things differently. It helps to understand how the different platforms work from that perspective. One more quick example, data engineering. So if you're working in AWS, you typically, your standard go-to architecture pattern for data engineering in AWS is likely to use Glue, which is based on the open source Apache Spark software. If you're in the Microsoft Azure platform, Spark again is very common either as part of Microsoft Fabric. So Fabric has Spark. It actually has other options as well, but Spark is a really common one. Or then Microsoft also have the proprietary data factory, which you may see as part of the platform and tooling as well. In Google Cloud, there is a managed service for Apache Spark until fairly recently called Dataproc. They've renamed it Managed Service for Apache Spark to make it clear that it is just a packaged version of that tool. But the default is more commonly Dataflow, which uses Apache Beam as part of the workflow. But Dataflow is the engine the Apache Beam scripts run on in Google Cloud. So if you're looking at the default architectures, those are what you see. But if your organization is already using Spark in various places and you're thinking of adopting Google Cloud, it's worth knowing that there is a managed Spark option there, even if it's not shown in some of the default architecture diagrams and so on. And there's a couple of other examples of that on the screen. There are more. If you do want to get into the specifics of what you should understand for your organization, either Ethan or I would be happy to talk to you afterwards. Just reach out to us and we can set up some time to talk through what you're doing and how we can get alongside and help with that. The final thing that I'll highlight in some of these platforms that I think is a bit interesting to think about when you're trying to adopt them is what I put in the bottom line here. Now, I've called it loved by. I will say these are somewhat more of an opinion than a statement of fact. But really what I'm getting to is that each of these platforms comes from a particular history. And so the way the platform is set up and the way that you access things within the platform kind of reflects that in a way. So AWS, when it was first set up, was really about how can Amazon rent servers to various different organizations. So it therefore is set up from the perspective of kind of infrastructure rental. And so for an infrastructure architect, you can go in, you can get your slot in the VM timing. AWS offers a lot more than just infrastructure rental by this stage, but a lot of the views in the platform are kind of lend themselves to that view of the world. Microsoft Azure then comes from their pedigree in enterprise software. So things like SQL Server through to the security in Entra ID, what was Active Directory, and so on. So Microsoft Azure has great interfaces for enterprise IT and governance and being able to see exactly what's being used, who has access to it, and so on. And so when you come into the Microsoft Azure platform, typically that's your first view, is what all is running within the platform. Google Cloud then set up because Google have all of this software that they're using internally, and they wanted to make that available to external organizations. So it's set up from more of a software engineer perspective, set up for developers who are writing a lot of code and want somewhere to run that code. And they provide some great tools to do that. But when you go into the interface, there's things like they will often couple the settings with the code when you deploy it. That makes it easier for a developer to just deploy everything in one go rather than having to think separately about, here's the code that runs my application, but I also need to think about setting up the infrastructure for it. So understanding the differences between the platforms helps you design the architecture specific to your organization, and thinking about, especially if you're using multiple platforms, how you get a level of consistency in the way that you think about an approach across the platforms. Honorable mention before I move on to Databricks and Snowflake, and there are other platforms as well, other tools as well, that allow you to work across the different cloud platforms. Both of those have one interface that you can use, whichever cloud platform it's running on. You can connect into the other tools within those platforms. And so we have some customers who have been using those as a way to kind of abstract, run things in common across one tool. So choose Databricks, for example. One of our customers using Databricks wants to move things from Microsoft Azure into Google Cloud, then it's really straightforward to move those things across. There might be a couple of the lines of the connections that need to be changed over, but by and large, the code works the same way. And so it's easier to move across because you're using that platform. So that can be one useful way to do it. Certainly not the only way. So getting Google Cloud ready, what are some of the key decisions that you want to think about? Again, these questions will be different by organization. So if you want a discussion, we can help with that. But just to give you some of the kind of starting point questions that you need to be thinking about. So what business use cases or scenarios do you want to unlock in Google Cloud? Especially if you're coming at it from a business question perspective, there's a business unlock that you particularly want to get to. Important to think what those are and identify the priorities from that perspective. Once you're onboarding the platform, then it's worth thinking, how are you going to make business users aware of what's available to them? If you're bringing in the platform because it unlocks new capabilities, then it's not just going to be the one or two users who suggested it, who that could be of advantage to. How do you make sure that you're setting up to get the rest of the organization using it as well? If you're looking at a true multi-cloud scenario, what are you going to use each platform for? For some of the regulations coming in around banking in the UK, for example, banks are having to think about replicating the same application across multiple clouds and actively running it on different clouds. But it's not every organization that wants to run or needs to run every application across multiple environments. So sometimes it's enough to have that application portable so that if I have the same set of code, I could deploy it on, I've been running it on Microsoft Azure in the past, now I want to move it to Google Cloud. Or if I'm building it for Google Cloud, taking advantage of that openness of the ecosystem, building it in open source software so that it's easier to run in Google Cloud. Google Cloud provides a great place to run some of that open source tooling. But if you do want to move somewhere else, maybe there's a cost to running that tool somewhere else, but you can do it. So that's what we mean by portability here. If, on the other hand, you're looking at one main cloud platform, maybe you're thinking of moving the core of what you do into Google Cloud. I'd say it's very common these days for organizations to run on multiple clouds, but you've got to think about where your main cloud platform is. Where very commonly organizations will have one main cloud platform. If you're changing that, then what's the migration approach? The target of moving everything at once, while it sounds like the easiest way to do it, quite often isn't. So it's more common to think about splitting it up into different parts. Do you move the new applications first, and as you innovate with the applications, update them, make changes to them, that's when you migrate them? Or is it that you want to move the kind of center of gravity and move your data first so that you create your biggest applications in the new cloud platform, right? There's different ways to think about it and how you do that migration. And then if you are combining data across platforms, what of the data lives where? What's your data replication approach? Which data needs to be replicated across the different clouds? Or are there particular data sets that it makes sense to have in one cloud? And then how are you managing security across all of that? So do you have user accounts that are synchronized across the different cloud platforms? Or are users going to have separate logins? or do you reuse the same login rather than just a kind of lightweight syncing? So there's different ways to do it. All of that is worth thinking about. And then there's the approach to architecture patterns. So think about what are your core architecture patterns, especially with the speed at which tooling is moving forward. You're not going to get one architecture that covers everything. You're not even going to get a set of architectures that covers every use case. The changes in this mean that there are always going to be some level of exceptions, or at least from what we've seen with every customer, every company is going to have specific scenarios that need some form of exception. But can you identify, maybe it's 10 patterns, it's 20 patterns that cover off, 80% of what you're trying to do. And in doing that, what we've seen with customers in the past across different cloud platforms, so not just Google Cloud, this is an approach that we've used in different places. We've seen that when we do that, you can get each project started faster, get up and running for those projects that can match one of those standard architectures. And that creates the space for you to properly go through and identify what needs to be done anytime that there is another tool to bring into the system. So create common patterns that cover the majority of use cases while creating a flexibility that allows you to bring in extra tools where they're creating extra value for the organization. And so there's some examples on the screen. I'm not going to go through, certainly these aren't architecture diagrams anyway, but I'm not trying to set out here what your main force should be. But I'm giving examples of the sorts of things that you might want to consider in some of those standard architecture patterns. So for example, take conversational search, the Gemini Enterprise Agent Platform, which includes what used to be Vertex AI, if you're used to that naming. So the Gemini Enterprise Agent Platform has a RAG engine where you can just plug in your files. So RAG is retrieval augmented generation. It's the way that we allow large language models to access PDF files, Word files, PowerPoint presentations, whatever it is. If you use RAG engine, it does all of that in one go. You just load it in and it surfaces it as a search engine that you can immediately use for the large language model to access. Or you could choose to use vector search, where it gives you a little bit more control in doing that. So you set up the process that takes that document, decides how to split it up, process it, decide what exactly gets stored in the search, and then you use the vector search for the large language model to access the information as you've structured it. So you've almost got to do a form of data engineering on the files if you want to do that, but it gives you more control. Or then there are some kind of specialized, so Search for Commerce is specifically designed to do searches over, say, a product catalog if you're working that way. So there are different tools that you might use in different contexts. So deciding within your common architecture patterns, which are the priority tools that you want to focus on. And that allows you to set up the architectures quicker. It allows you to get your teams, focusing on the right set of skills that you want to build. So which tools are you going to build the most skills in to be able to support those? And it gives your wider team more direction in terms of the tools that are available to them as well. So talk quite a bit about how to think about getting set up for the platform. But now I'm going to hand over to Ethan to talk about those couple of specific case studies and really bring that to life in terms of how we've done that in some specific scenarios.
So Andrew talked about some of the reasons why Google Cloud has become such a compelling option in the cloud platform space in recent years, and some of the steps that you should consider taking to make your organization Google Cloud ready if you're considering making the switch or you're already in that process. Now, I'd like to take you through a case study where we've helped one of our global consumer packaged goods customers in the early stages of making that switch. But before I get to that, I'd like to talk about what we've built in our own Thorogood internal AI workbench on Google Cloud. So with AI moving very quickly nowadays, it's becoming more and more important in our everyday workflows. And we knew it would be important for us to provide Thorogood consultants and our core functions teams with access to a secure system where they can use AI tooling. And besides the need to simply provide an AI chatbot that's secure and private, we also have a whole host of internal data, so documents, databases, and other data. And connecting this into a central AI tool to bring this data together with a simple interface to query them all is a real bonus for us. And then there's the potential to introduce agents into our workbench so we can automate specific tasks and free up more of our time to focus on our customers and delivering solutions. So you're probably thinking, why build this on Google Cloud and not AWS or Azure? And as we see it, really comes down to two reasons. So the first of those is that Google really promotes using open standards, even in its proprietary tooling. So Google's Orchestrator, their main orchestrator on the cloud platform, is a managed version of Apache Airflow, formerly known as Cloud Composer. They also have Cloud SQL, which is their main SQL tool, and that hosts multiple open source databases. We want to keep our platform open so as not to get locked into a single provider. And of course, it's possible to deploy a completely open source architecture on other cloud platforms, but open source is the default with Google Cloud, and we really like that. So the second reason is Vertex AI, or Gemini Enterprise Agent Platform, as it's now known. Google is the only one of the three major cloud vendors that develops their own frontier model, and will therefore be tightly integrating that into Vertex AI services. By building our AI platform on Google Cloud, we're in a great position to access this tooling. And it's worth noting, though, we're not locking ourselves down to Google models or even hosting all of our models on Google Cloud. We're also connecting to other model endpoints hosted in Azure and AWS, so we're able to access the widest range of models possible at the most competitive serving price. So that was our internal workbench, but now I want to talk to you about an interesting challenge that we worked on with a global consumer goods company. So the context behind this is that they came to us a few months ago as their customer development director was keen to use Google Cloud for analytics in their specific business function. But as conversations developed, the need that they had actually spread wider, and the company made it clear that they'd like to understand more about Google Cloud with a view to adopting it more widely over their existing Azure architecture. Now, with a company of this size that holds a vast amount of data assets and has a large number of complex data pipelines, migrating their platform from Azure to Google Cloud was not simple, and it came with a few key considerations. So firstly, all of their infrastructure, design patterns, and crucially expertise were in Azure and Databricks, which meant that it was more feasible to replicate the setup that they had in Azure in Google Cloud, where this was possible and it made sense to do so. It was also clear that their data should be accessible across cloud platforms so that systems could be migrated seamlessly over time. So we were asked to help them map their proven approach in Azure to Google Cloud, documenting the recommended architectural patterns for key use cases on Google Cloud and taking into account key considerations that we put on the screen in doing so. We then tested these patterns thoroughly to ensure that they were efficient and feasible for the company's needs. So I'll now cover a couple of those patterns that we documented. And the first of those is data engineering. And the reason I'm covering data engineering first is that data engineering is key for an organization which processes large amounts of data about their products, customers, and sales every day, like our client. Data pipelines underpin reports that are used by decision makers to make key decisions in the organization. So it's crucial that the architecture behind it is robust. The company's existing architecture was Azure-based, with Databricks at the heart. And the vast majority of data transformation, governance, and even some data analysis was done inside Databricks itself. So it was really crucial to their data strategy. Azure resources such as ADLS, SQL Server, Data Factory, and Key Vault were mainly used to assist Databricks when it was doing the heavy lifting. And another key aspect of their platform was access control and security, which on Azure is handled through Microsoft Entra. And these permissions propagate down to other resources like Databricks. If we contrast this to our proposed architecture in Google Cloud, you can see from the diagram on the screen that not much has changed here. We've kept Databricks at the heart of the architecture, opting to keep it rather than migrate logic to something like Dataflow on Google Cloud. The reason for this being that Databricks is multi-cloud, and this decision allows the company to reuse all of their data transformation logic and governance patterns from their existing architecture. So it's very practical. As a lot of the core services that cloud providers offer do similar things, Google Cloud offers like-for-like alternatives to many Azure resources that were used in the previous architecture, such as Google Cloud Storage, Cloud SQL, Secret Manager, and Managed Service for Apache Airflow, which, as I mentioned earlier, handles orchestration. And it's worth noting that unlike Data Factory, Managed Service for Apache Airflow runs the open source orchestration tool Airflow, meaning that you aren't locked into running your orchestration on this Google service when you've built your pipelines using it. You can migrate to any other kind of cloud, any other service, and use those Airflow pipelines as they're entirely open source. So now this might seem fairly simple on paper to make this architectural change. There are some intricacies to navigate when moving cloud providers. And one of those that we found is that the general structure of Google Cloud is very different to Azure. And Andrew touched on this a little bit earlier where he was comparing the three major cloud platforms. So you need to think very carefully about how you organize your resources at an organizational level. Another issue that we found or challenge is that identity and access management works very differently on Google Cloud, with service accounts being used far more often than in Azure, where it's generally preferred to use managed identities. And even though we use Databricks in both architectures, the way Databricks interacts with other services on Google Cloud can be quite different. So these intricacies do need to be tested and managed well. The other key pattern that I wanted to cover was the AI and machine learning pattern. And here, Databricks 2 has really great tooling available for building both AI and machine learning models. So including foundation model serving, managed MCP servers for Databricks tools, and a vector search index offering that's built into the Databricks platform. So this really raises the question, why not just use Databricks here as well? And there are a few reasons. In the case of AI, the landscape itself is very competitive. It's crucial for companies using AI and building it into workflows to stay flexible with their AI tooling, so they can't get locked into one provider. And with this in mind, the key strategy is to keep your options open. And one way you can do this is by using multiple model serving providers. So Amazon Bedrock, Gemini Enterprise Agent Platform from Google, and Azure AI Foundry are some of the main three. But if we focus on Google here, our recommendation to the company was to develop AI architecture patterns in Vertex AI, as well as in Databricks. This has the advantage of opening up the benefits of native integration with Google models through Vertex AI and any features that come with that. As I've mentioned before, though, it's important to use open libraries and tools as much as possible so that you maintain flexibility in this rapidly changing market. And Google Cloud encourages you to build AI tooling in this way through Vertex AI. And that was really our main recommendation with this architecture pattern to the company. So we've covered a lot of ground here, both Andrew in the first half and me in these case studies. We've talked about why GCP matters, how to get it ready, and we've gone into some real examples of how we've helped organizations like yours navigate this journey. So the question now is, where do you go from here if you're on this path? Well, with Google Cloud, like any technology, it's important to understand both the goals of your business and the possibilities of the technology that you have available. Our approach at Thorogood does just that. We take time to understand your business and your goals and have a deep expertise of a wide range of data and AI technologies, including Google Cloud. This allows us to help you understand the opportunities for your organization when moving to Google Cloud and how you can seize those opportunities in the right way. So thank you very much for joining. If you'd like to hear more of our perspectives, you can go to thorogood.com/perspectives. Or if you'd like to talk to me or Andrew about Google Cloud or anything data and AI, our details are shown on the screen and we'd love to hear from you. Thank you very much.